Hi everyone, this is Nepal Reddy sir from ANR Academy. Today I am here with you to discuss about trigonometric ratios on unit circle. See in this figure, there is a circle whose radius is 1 unit. Suppose that here it is origin. Since radius of the circle 1 unit, here it is the point whose coordinates 1, 0. Let us suppose there is a point P on the circumference of the circle, and in general the point P whose coordinates is denoted by Px, y. Since radius 1 unit, if you join center with P, then the length of OP also radius, and clearly radius of this circle is 1 unit. Let us suppose if you drop a perpendicular from point P to x-axis and assume this, here the point of intersection, suppose some M. Clearly, if it is the point whose coordinate x, y, then O to M the distance is clearly x units, and P to M the distance is y units. And suppose that theta is angle made by OP with positive direction of x-axis in the counterclockwise sense. Now I am going to write sin theta value and cos theta value from this triangle OMP. From triangle OMP, first I am going to write first trigonometric ratio, that is sin theta, and then cos theta I am going to write. We know that sin theta, that is opposite divided by hypotenuse. Here theta opposite you have y and hypotenuse is 1. So it is y by 1, nothing but y. Next, cos theta. You know that cos theta is defined by adjacent by hypotenuse, and here adjacent to theta you have x, and hypotenuse, that is radius of the circle, 1. So that clearly x is nothing but cos theta, y is nothing but sin theta in this case. So now I am going to mention first two trigonometric ratios, sin theta and cos theta, on unit circle. If it is unit circle, if you drop a perpendicular from P to x-axis, then the distance O to M, this is known as cos theta, and this is clearly sin theta. Two trigonometric ratios over. Next, suppose that if you select a tangent at point P with respect to this circle, yes, see here, suppose that this is tangent with respect to this circle, that is with respect to unit circle at the point Px, y, and assume that the intersections on x-axis and y-axis. Suppose that here the intersection some n, another point of intersection here on y-axis. Suppose that this is some q. Now I am going to use the triangle OPN. I am going to use the triangle OPN now. From the triangle OPN, since it is tangent and OP clearly passing through center, and this is known as normal with respect to the circle. Normal always passes through center of the circle, and this is tangent. So angle between tangent and normal, you know that is of 90 degrees here, and also here you have 90 degrees. I am going to use the triangle OPN first. From the triangle OPN, I am going to write tan theta. We know the definition of tan theta, the ratio of opposite and adjacent. Opposite to adjacent is the formula. Observe the triangle OPN. This is OPN. Clearly, opposite to theta, you have PN, and adjacent, theta adjacent value here, it is 1. Opposite PN divided by adjacent. Theta adjacent is clearly 1. So from this it is very clear that PN is nothing but tangent angle. So this is known as tan theta on unit circle. That is the distance covered from the point P, which is on unit circle, to the point of intersection on x-axis. That is known as tan theta. Next, then I am going to use another triangle. Here the triangle OPQ. Next I am going to use triangle OPQ. From triangle OPQ, if you write cotangent angle, that is cot theta, if you write, you know that it is adjacent divided by opposite. I am going to use the triangle OPQ that you have here, OPQ, and whenever it is of theta, this is automatically 90 degrees minus theta. Since it is of 90, this is the angle theta now. Sum of the angles should be 180 degrees. Here minus theta plus theta gets cancelled. 90 plus 90 gives 180. So sum of internal angles of this triangle now 180 degrees. After writing here 90 minus theta and theta here 90, it is very clear. From that diagram, you have to express cot theta. Adjacent to theta you have PQ, and opposite to theta you have radius, that is 1 unit. So here it becomes PQ divided by 1 gives the result PQ, and hence I can write distance from P to Q. This is cot theta. Next, two trigonometric ratios done, and then we go for secant theta and cosecant theta. See, from triangle OPN, I am going to write secant theta. Using this, I am going to write secant theta. What happens? Observe. Secant theta is nothing but hypotenuse divided by adjacent. And from the triangle OPN, what is hypotenuse? Hypotenuse is clearly O to N. Next, this one is opposite and this is adjacent to theta. Theta adjacent radius, that is 1. So clearly ON is secant theta from this. So O to N, from O to N, this is clearly secant theta. Next, here from the triangle OPQ, I am going to write cosecant theta. What happens? Observe. Cosec theta can be expressed as hypotenuse divided by opposite. Observe the triangle OPQ. This one is the triangle OPQ, and we have to express hypotenuse and opposite. Theta opposite you have 1. So here denominator part become 1 and numerator hypotenuse is clearly OQ. So it is OQ divided by 1. It gives the result OQ, and hence the value of OQ is cosecant theta. O to Q, this is known as cosecant theta. So that remaining two trigonometric ratios are also expressed on unit circle. See, if there is a unit circle, on Cartesian coordinate system, I repeat, here it is origin, and somewhere assume that the point P on the circumference, O to P, the distance is clearly 1 unit due to unit circle. Unit circle nothing but the circle having 1 unit radius is known as unit circle. If you drop a perpendicular from point P to x-axis, and if it is of M, and here suppose that if it is some R, and assume that this is some N, and here the intersection suppose that Q. Now at a glance I am going to write all the trigonometric ratios. This is known as cos theta, that is horizontal component is cos theta. Next, vertical component up to here, it is sin theta. First two trigonometric ratios. Next, P to N, this is tangent angle, tan theta, where theta is angle made by OP with positive direction of x-axis in the counterclockwise sense, remember. And this is clearly up to here it is cot theta. And from O to N, this is secant theta, and from O to Q, that is cosecant theta, remember. So this is about trigonometric ratios on unit circle. Sometimes very lengthy proofs, by using this result you can easily solve. Let us discuss normal form. You know the normal form of equation of straight line. What is normal form of equation of straight line? X cos alpha plus y sin alpha equal to P. here if the circle of radius 1 unit, this is sine theta and this is cos theta and this is tangent, cotangent, secant, cosecant. And if suppose the circle is not of 1 unit radius, assume that it is of some radius r, then what happens when it is of radius r, then automatically if it is r, then it become r cos theta, r sin theta, r tan theta, r cot theta, r cosec theta and r secant theta. Suppose that if it is not 1, I am going to select radius in general. Then in such cases you have to mention here r sin theta, it is of r cos theta, it is r secant theta, it is r cosecant theta, it is r tan theta and it is r cot theta. Remember, when the circle is of radius in general r, then the trigonometric ratios are multiples of r. See, in the proof of normal form x cos alpha plus y sin alpha equal to p, if you know this result, you can directly write the normal form simply x cos alpha plus y sin alpha equal to p. Let us observe. In the normal form, a line, it has normal and normal of length p units, and normal makes an angle alpha with positive direction of x-axis in the counterclockwise sense. You know this result. If alpha is angle made by normal to this straight line with positive direction of x-axis in the counterclockwise sense, then the equation of line, this line can be expressed as x cos alpha plus y sin alpha, it is equal to p. You know, this is the statement. And how here t ratios on unit circle or t ratios on trigonometric ratios on any circle, how it helps in the proof of normal form, let us discuss now. Clearly here if you select a circle, it is of radius p. Remember, there is a circle of radius p and this is acting as a tangent. The line acts as a tangent with respect to a circle whose radius p, and here the angle of inclination is alpha. Now I can write from origin to this point of intersection. See here, from origin to point of intersection, this is clearly the distance r, radius multiplied by secant theta. So here I can write x-intercept. X-intercept, I can write radius p secant alpha here. Okay. Next, y-intercept. We know that y-intercept p cosecant alpha. Let us see in the previous discussion. R into cosecant theta, that is y-intercept of the line. Now, I am going to use intercept form. What is intercept form of straight line? X by a, nothing but x by p secant alpha. Next, y by b, that is y by p cosecant alpha equal to 1. 1 by secant alpha written as, here in the denominator part you have p in common, transfer p to the right part, 1 by secant alpha written as cos alpha. 1 by cosecant alpha written as sin alpha. So you got the result, x cos alpha plus y sin alpha equal to p. That is normal form of equation of straight line. So on problem solving, trigonometric ratios on unit circle and trigonometric ratios on circle with any radius helps us on problem solving in the objective type of questions given in the examinations. So be careful with t ratios on unit circle. This is r cos theta, this is r secant theta, and this is r sin theta, this is r cosecant theta. On tangent you have r tan theta, r cot theta. I hope you understand everything. If you like this video, please like, share and subscribe this channel. Thank you so much.